Have you ever looked up at the night sky and wondered how we get those massive rockets off the ground and into space? It seems like magic, but it's all about some seriously cool science. Let's break down how a rocket ship actually works. At its core, a rocket operates on a very simple principle: Newton's third law of motion. For every action, there is an equal and opposite reaction. Think about blowing up a balloon and then letting it go. The air rushes out one way, and the balloon zips off in the opposite direction. A rocket does the exact same thing, just on a much, much bigger scale. Instead of air, a rocket uses propellants. Most modern rockets are chemical rockets, meaning they mix a fuel and an oxidizer. The oxidizer is crucial because there's no oxygen in space to burn the fuel. When these two chemicals are mixed and ignited in a combustion chamber, they create a massive high-pressure, high-temperature explosion of hot gas. This is where the magic happens. All that hot gas has nowhere to go except out the back of the rocket through a specially shaped nozzle. This nozzle, called a de Laval nozzle, is shaped like an hourglass. It accelerates the escaping gas to incredible speeds, sometimes over 10,000 miles per hour. This massive blast of gas, shooting downwards, is the action. And what's the opposite reaction? The rocket itself being pushed upwards with immense force. This upward force is called thrust. To get a rocket off the ground, the thrust has to be greater than the force of gravity pulling it down. That SY launch is so loud and powerful, the rocket is literally winning a fight against the entire planet's gravity. But getting into space isn't just about going straight up. The rocket needs to go sideways, really, really fast, to achieve orbit. Imagine throwing a baseball. It goes up, and then gravity pulls it back down. Now, what if you could throw it so fast that as it falls, the Earth's surface curves away from it at the same rate? The ball would just keep falling around the Earth forever. That's what orbit is. It's essentially a constant state of falling. To do this, rockets use a technique called a gravity turn. Shortly after launch, the rocket starts to tilt slightly. It uses its momentum and Earth's gravity to gracefully arc into a horizontal path. This is much more fuel efficient than trying to fight gravity all the way up and then making a sharp turn. Most large rockets are also multi-stage rockets. Why? It's all about weight. Carrying empty fuel tanks is like a hiker carrying an empty backpack. It's just dead weight. So, once the first stage of the rocket has used up all its fuel, it detaches and falls away. This makes the remaining rocket much lighter, so the second stage engine doesn't have to work as hard to accelerate it to orbital speeds. Some rockets even have 3 or more stages to get a payload all the way to the moon or other planets. Once in orbit, the spacecraft can turn off its main engines. It's now coasting, balanced between its forward momentum and Earth's gravitational pull. Smaller engines called thrusters are used for maneuvering, changing orbit, or docking with other spacecraft, like the International Space Station. So, from a simple balloon to a multi-stage behemoth, the principle is the same. By throwing mass out the back at incredible speed, we can propel ourselves forward, breaking the bonds of Earth's gravity and exploring the cosmos. It's a beautiful dance of physics, engineering, and human ambition. Thanks for watching. If you enjoyed this deep dive into rocket science, be sure to hit that like button and subscribe for more space explorations. Let me know in the comments what other cosmic topics you'd like to see explained. See you next time.